Yes, maybe something new or something else. I think at the beginning of the call, you asked something with Ross and said he's working on the MPC. Maybe he can tell us something interesting. Yes, something new. I think it with the MPC, or it's don't know. Maybe it's it's all private with REN 2.0, or I think the SMPC area is also very interesting, and it's it's a time very quiet. Or you said you cannot talk at the moment about new SMPC features.
I mean, yeah, Ross, you don't have to spill all the secrets. But if there's
Uh,
anything you want
I
to,
mean,
you can mention and go ahead.
I mean, well, yeah, I can talk about the stuff that's public, I guess. I think is most of it. But let me double check what is public. So like the Frost repo is public, right?
Yeah, latest
I believe.
update was 7 days ago, so maybe you have a development branch that is more recent, but
Yeah, I mean, I guess, yeah, I mean, it's just we, in the older version of Ren, we had an MPC algorithm that we developed ourselves, and we put a paper out for that. But we didn't like how it scaled. Like if we're going to have thousands of nodes, we would need to break that group up into shards for it to be performant. So we were playing around with trade-offs, and we saw that Frost, which is sort of a recent paper, fairly recent paper that got published, had quite good scaling. It had some drawbacks, but we decided that it would be good to go with that. And the idea is that we would have, we don't need to have shards, which simplifies some things, which would be nice, and theoretically sort of more secure, because if there are 3,000 nodes, then we could make it so that you have to corrupt 1,500 or more of them to be able to recover the private key, which is would be quite challenging. So that's kind of like the main, I guess, novelty in that realm.
is the idea that there will be absolutely no shards then in the
There still can be, but we, at least with this, we have the possibility of just having a single shard, basically. Which, like I said, when you split shards up, like say there are 1,000 malicious nodes, I don't know how that would happen. And if you just have one shard, then they can't possibly recover the private key. But if you say break it up into 10 shards, you sort of do that randomly. There's a chance that one of those shards has enough corrupt nodes that they could recover the private key. So it's generally sort of a bit nicer to have a single shard. You can be a bit more secure.
so the MPC algorithm is able to split a key up into 10,000 pieces.
Yeah, like even the one we were using in the previous system could do that, but it just didn't scale as well. So like when you go to do a signature, a distributed signature, if you had like 3,000 nodes, it would take kind of a long time with the old system. But with Frost, it'd be fairly fast, like, a couple of seconds or something in terms of computation, I think. So it's, yeah, like you could always, like, yeah, you can break, there's no limit on how many pieces you can break a private key up into in terms of secret sharing.
So is that operation when Ren has to sign something, would that be separate from the Ren EVM layer itself? If there's a catalog on Ren EVM and there's a just a swap between Bitcoin and Ethereum, but it's all sort of contained within Ren EVM, so no Bitcoin is actually sent out to a different address, then the MPC algorithm is not used, and there's no like scaling issues there. Or
Yeah, I'm not 100% sure what that part of the system looks like, but theoretically, every time you need a signature, and you need it to be signed with the distributed key, then Frost will need to be used. But if you don't need a signature, then it doesn't need to be used.
Okay, so then Ren EVM could sort of be like a layer 2 that aggregates a bunch of transactions into just like one signature needed on the dark node level.
Yeah, I don't see why not. But like I said, I'm not super familiar with that part.
Yeah,
how that's going to look like.
But I'm assuming like if we have a bunch of applications on Ren EVM, if a signature takes a few seconds, then your TPS wouldn't that be sort of like, you know, 1/3 seconds? So like, no. Then your TPS would be like 0.3 or something if it takes 3 seconds. So that wouldn't be a good design, I guess.
Well, I mean, this is sort of like, I think those metrics are sort of in the limit. If like there were, 5,000, 8,000 nodes all going at once or something. I think with the lower number of nodes, it's faster. And then there's, like you're suggesting, there's also ways to sort of aggregate or like do signatures in a batch. So, but also, I believe, like, even just ignoring all those possibilities, like, say you have a Bitcoin signature you want to do. I mean, a transaction can have multiple, like, move multiple funds from different accounts and things. You will need potentially more than one signature, but like, yeah, like what the signature is used for can represent a lot of transactions potentially.
Because, I mean, that's how Optimism and Arbitrum, at least, how they scale. They don't have to post everything to the layer 1. They aggregate it, but
yeah,
I guess Susur.
Anyway, like I said, so with a smaller number of nodes, like with fewer than 1,000, I think it'll be very fast. And if it turns out that we do have like 8,000 nodes in the system, and it is taking like a couple seconds or something, I mean, we can at that point also again consider sharding to bring the total number the number down in terms of who's participating in a signature, and then we can get performance back that way. So I think there's lots of possibilities.
Is there do you have a graph of how time increases per node?
I just ran some simulations locally. Let me see if I still have them.
Because is it like exponential, or is it linear, or how does it?
Right. I guess I think it'll be probably like n squared.
Yeah. Okay.
Which is kind of what you would expect for MPC algorithm. I'd be surprised if you could do better than n squared in most cases. Let me see.
Yeah, go ahead.
I was just going to say, I just put up this file that has it's simulated 3,000 nodes and threshold of what is it? Threshold of 1,500, so like 50% 50 threshold, and Yeah, it looks like 500 milliseconds on my machine. And if you looked at something like with 300 nodes, then it's down to like 15 milliseconds.
Okay, yeah, that's a massive difference.
Yeah.
Because I mean, when Ren was first conceived, this limit of 10,000 dark nodes was completely arbitrary, I guess.
Yeah.
I mean, how many nodes do you need in a decentralized network? Like, how many does Ethereum have? How many does Bitcoin have? Like maybe the 10,000 limit is too high, or you do sharding, as you say, but sharding introduces, I guess, some complexity that's big.
Yeah. It would be good to avoid it, but it's always a possibility.
Was
You
right,
know, yes.
right now we have 2,000 community nodes. How much would that be, Russ?
I don't know. Without running the simulation, you're going to find interpolated. It might be something like, I don't know, 100 milliseconds or something.
Okay.
Hard to guess.
So that's at least 10 TPS, which is more than Bitcoin. So,
Yeah.
yeah.
But this is also depends on the machine and everything. These are like very rough numbers.
We know how many, how is the max of TPS with Ren 2.0, or you can't say at the moment anything about it?
No, so that was exactly what Ross was talking about right now. It depends on how many nodes you have in the network, I guess, and the hardware of the nodes. So to say there were 2,000
Yes, why?
nodes, as I just asked, then it could the MPC algorithm could do 10 signatures per second. That doesn't have to mean like that's what Ren EVM can do. It's just how many, like, say there were exactly, say it was only bridging transactions, then it could do 10 of those per second, which is way more than that's likely, or way more than what's going on at the moment. 10 TPS would cover a long way. But if Ren, so if we would have 5,000 nodes, then maybe we'd have to consider how we can improve those stats. Because then so it depends on the number of nodes and how beefy the nodes are. So there's no like number. You can't say like Bitcoin has exactly one type of TPS, but that's because that's how their consensus mechanism is designed to try to, on average, have a block every 10 minutes. But that's not how Ren would work. So it would all depend on node count and how powerful the machines are.
So there's completely different to Solana, Aptos, and all the other blockchains.
I mean, I think they also kind of have similar. They do it in a similar way, and that's why like the Solana hardware requirements are so high. They also it also comes down to consensus mechanism. But Ross, is the MPC itself a consensus mechanism, or how does that? You just need to wait for at least half of all the nodes to sign something.
It's a little different. It's like, there's a series of steps. Like, there's like a couple rounds. First round, everyone sends this kind of message. In the second round, everyone sends this kind of message. They're all sort of just like sending and receiving messages and checking that they're correct and no one's being malicious. And then they do some computations with them, and then they put the result together. So it's not really consensus. I mean, it is sort of in the general sense of the word, but not in the like specific cryptographic sense, I wouldn't say.
So, but does REN then need a separate like consensus protocol, or is that
Um,
how does that work?
not yeah, I guess I'm not 100% sure on what the ideas were, but you know, I believe what they've done with the Ren chain or like the Ethereum fork thing. I mean, since they've forked Ethereum, that is like consensus, right? That involves like I assume that they're using like the Ethereum consensus code. So yeah, that's like consensus code would be in there and be using that, I would presume.
So that potentially adds some time to how often the signatures can be done by the dark nodes, if they also have to handle sort of some consensus networking additional.
I mean, potentially, but I mean, they are sort of like generally independent. So almost every machine has like more than one core. So they could, I imagine they would just run in parallel and like wouldn't really step on each other's toes. I don't think it would. I wouldn't predict there to be like an additive effect.
So the signature part can only be run on one core, or
not necessarily. Just that I was just making the point that like the consensus computations they're independent from the signature computations in a way, so they can run on separate cores and
okay, cool. How much bandwidth does sort of Frost use? Like, have you done measures on like what's the how many megabits per second do you need for it to
Just have a look. Just let me double check what's in my little simulation. I think it was going to be something on the order of like 100 kilobytes ish per signature. On that order of magnitude.
Okay. Yeah, I mean, most people have at least above 10 megabits per second, so data centers
have be a problem.
But that, so say consensus isn't the bottleneck; it's the MPC part. Would then the speed of the network be the median of the slowest part of the whole set? Like, do you understand what I mean?
Are you wondering about if different machines have different speeds?
Yes, so say there's 1,000 machines, and there's 500 that are faster than average, 500 that are slower than average. So would it be the median, like the speed of the median node of the 500? That would be the bottleneck, would it?
Yeah, I guess roughly. I mean, how it works is usually like there'll be a like you say you've got 2,000 nodes. There'll be like a sort of random subset of like 1,000 of them that will do any given signature. So it sort of like depends on. So it's a random in that sense. So it depends sort of like if you pick a like subset of really fast machines, then it'll be a bit faster. But in general, you will have to wait a little bit for the slower nodes. But yeah.
Oh, super interesting to hear these details, because we haven't discussed them that much in public.
Yes. so that you can also do with SMPC other things, apps and private calculations and everything else. There must be difference and much change that you can do something with the SMPC, or does it work with the REN 2.0 and the Frost section?
So you're sort of wondering if SMPC can be used to do more general calculations.
Yeah, I think that's what he's wondering. Yeah.
I mean, in general, yes. The problem usually with having a system that can do general calculations in MPC is that it's usually not very efficient. So it's almost always better to have like a specially crafted MPC algorithm to do a certain thing. So that's like what Frost is. Frost is MPC, but it's specially crafted to do signatures. If you took like a general computation MPC algorithm and did like a signature with it, it would be pretty horribly slow. So there's definitely like the opportunity to expand what we do in MPC, but if we're using thousands of nodes, I think generally you'll need to use sort of more specific, more specially crafted algorithms to do whatever it is that you want to do.
Oh, nice, thanks.
Could those could the darknet client have sort of a separate MPC algorithm for so that would be like less intensive? Could those run in parallel then as well? So for those different kinds of tasks?
Well, yeah, I mean, in general, if you have sort of tasks that are independent and they work on like independent data, then you can make them happen in parallel. But then, yeah, it's a matter of scaling up your machine, right? Like, if there's 10 different things you want to be doing at once, you need to have at least 10 cores or whatever. So, yeah.
So is there anything like you think is really cool about Frost, or some kind of feature that's just I don't know, like pretty interesting? Like how come aside from scalability and those things, like how come you looked at Frost in the first place, and why not some other one?
I guess the main thing is scalability. That was really attractive. The idea of having a single shard is kind of cool. But another thing that it has, now it's not the case that no other threshold signature algorithms have this, but I think a lot of the major ones don't have this protection. Our old one did, but the protection is against attack where if you can run many signatures in parallel, so say you start doing an MPC signature and then before that finishes, you start many other ones, say like, I think on the order of like 200 of them. There's actually an attack where you can sign an arbitrary piece of data, which is like pretty bad attack in the sense that like that's pretty catastrophic. And I think a lot of threshold signature algorithms don't protect against that. So theoretically, if someone knew that what they were doing and they could start 256 simultaneous signatures or even less than that potentially, then they could craft a malicious signature and do whatever they want with it. They could sign a transaction that just drains all the funds or something. But Frost is protected against this attack. You can run as many signatures in parallel as you like, and the attack doesn't work. That's also a cool feature of it. But like I said, our old system had that feature as well. But certainly something that you'd like to have.
Yeah, and so we use MPC together with Shamir secret sharing? Is that still how it would work?
Yeah, I mean, it's not exactly how I would put it, because I mean, community secret sharing is kind of like the basis for the MPC. It's like a fundamental aspect of it. So it's not like two separate things necessarily.
No. Okay. Yeah. Because before we had when we documented the first round 1.0, so if you had control over 1/3, you could sort of use those secret shares to derive the full private key. But now
Yep.
it seems like we're talking about you would need 50%. So how does that? How do we
Oh
get
yeah,
this big boost?
that's a good point. In our old algorithm, the techniques we used sort of limited the threshold to 33% basically. With Frost, and this isn't unique to Frost, but it's another benefit of Frost, is that you can set the threshold to whatever you like. So I was just using 50% as an example. It's probably a pretty good ballpark figure of what we might like to use. There is just the trade-off that, you could make the threshold 100%,
Yeah.
obviously.
Yeah.
But now that causes liveliness issues. If one person, now you need every single node to participate to complete a signature. And so it would only take one person to not participate to sort of halt the system. So it's kind of like this inverse trade-off between liveliness and security. And 50% is probably a good place to be. You would need 50% of the nodes to be malicious, and you would also need like 50% of them to be completely offline or not participating.
So liveness and so before we could have liveness up to 1/3, and then
Yeah.
And then there was 2/3 for how was it?
It was a third for both.
A third for both.
The
Okay.
old one.
Okay, so now it's half. It could be half for both.
Yeah.
Okay. Well, that's that's pretty amazing. We haven't celebrated that too much, but that's pretty awesome.
Yeah, like I said, there are other, they existed at the time, these sort of signature schemes where you could have an arbitrary threshold. We picked what we did last time with the original version because the liveliness issues for those older options, we didn't really like we didn't like that trade-off. We felt like it would be a bit too easy to halt or slow down the system by not participating. But we've changed our minds slightly a bit on that trade-off, and I think Frost is also maybe slightly better in that regard. I'm not 100% sure. So we're
I mean,
mainly we sort of reevaluated the trade-off.
Yeah, and the flexibility of being able to set it wherever we want is, that's amazing. Because those things are sort of hard coded in Bitcoin, 51%, sort of. Yeah, because if you get that, then you can control the chain. But
yeah, it's kind of like an emergent property of Bitcoin that it has that security threshold.
Yeah. But we were able to set whatever we want, so that's pretty cool. Because then we could theoretically change it in the future if we found some threshold to be.
Yeah, like we could do 60 or 70% if we decided that we only wanted like 30 or 40% liveliness just to get that extra security,
Yeah.
Yeah.
Because I think Tenor, like all the Cosmos chains, I think they are 2/3.
Yeah.
So theoretically we could do that, but that ties into slashing and those kinds of things. Because if people aren't disincentivized if they aren't disincentivized to turn off their nodes, then if they turn off their nodes, then we can face liveness issues. So, have you thought about how to set the incentive/disincentive scheme for nodes participating, making sure that they're staying online? And
No, I haven't discussed that. I don't think there's any decisions being made on that yet. But as you suggest, it's kind of, I mean, there's a spectrum, right? You know, if someone sends a completely incorrect message, we can pretty safely say they're being malicious and can slash them. But, you know, if they just sort of like didn't respond in time, that's kind of a gray area because they could have been maliciously waiting, or they could just be having bad network, or you know, or some downtime for the cloud provider or whatever. So yeah, there needs to be some care in terms of making sure that people don't get punished for things that they shouldn't get punished for. Still not allowing malicious nodes to sort of continue to act up. So yeah, it's a tricky question, but you know, there's a few ideas like having a reputation. Like if you make one of these like gray zone mistakes many times, then we can start punishing you. But yeah, all things to sort of work out.
How quick does it, or how long time does it take to do a key rotation, and how sort of challenging is that? Because let's say that the network is noticing that a third of the network isn't responding quick or not at all. Could that be like some kind of threshold to do a new key rotation scheme, and then you would sort of go back up to 100% because only those who participated get to be involved, and you sort of do a dynamic key rotation scheme based on the liveness of the network itself? Or is key rotation like very time consuming and it would sort of pause the whole network for a long time? Or?
I mean, I don't think it's not like orders of magnitude slow or anything. It is a bit slower, and we're generally fine with that because you know you do it once an epoch or whatever.
But could you do it dynamically based on network health? Let's say that's the term for it.
I mean, yeah, sure. Like this is all like, you know, we decide when, like we as in like code, the nodes all decide, you know, they're programmed to do whatever you want them to do, right? So you know, there could be something where it's like, oh, you know, we tried a signature 3 times and there was liveliness issues and it failed each time. So now we're going to create a new key and transfer the funds to that key or whatever. You know, you could, you know, the sky's the limit. You can do whatever you like.
So how versed are you in networking? Because I listened to some podcasts on the Bitcoin networking layer, and one kind of attack is called eclipse attack, where you sort of trick nodes into knowing who are honest nodes. You kind of sort of isolate honest nodes with a layer. Some attacker spins up a bunch of nodes that sort of isolate part of the network, and that way they can trick them into maybe thinking that the network isn't healthy or something. Like how does when you use the Frost MPC, like do nodes know which nodes are honest and which aren't, and does it keep tabs on all nodes, or can they sort of be eclipsed? Can they be blocked from knowing from other nodes, so they don't see their signatures, so they're
well, I mean, in general, I guess. Just let me think about that for a moment. So, I mean, in general, the sort of logic is going to be a bit separated. So, the way I'm writing Frost and the way it's sort of written at the moment is, you know, there are it like does message handling and you know it does like the cryptographic checks and everything. Then, you know, when there's like an error, which is like potentially malicious message or whatever else, you can like report that information, but the system that deals with that information is not like in place yet. So, you know, and that's where that sort of logic would happen. You know, it's like, oh, I see that there were like this node presented and like gave a bad message, and these 3 other nodes didn't respond, and whatever. There'll be all this information that like you would need to decide how to act upon that. I don't know exactly in terms of that specific case of what you were talking about with Bitcoin. Not 100% sure how Bitcoin nodes identify with each other. I don't know if they have like a private key, public key infrastructure with like authenticated secure channels between each node. But if they don't, that is something that we do have in the dark node. So that would mean that, when a dark node is connected to another dark node, they know 100% that they're talking to that dark node. Like there's no, can't trick them to say that you're talking to someone else.
So how do they know that they have 100,000 Ren bonded in a contract? How is that authenticated? Because
I'm not familiar with that part of the system, but I presume there'll be like a registry of some kind on the blockchain. When you register a node, you have a public key identity, and that gets listed in this registry. And the only way to end up in the registry is if you bond 100,000 Ren. Then that public key identity is what you use to like when you're talking to other nodes, and you can say, okay, I'm talking to that identity, and in that way, be sure that you're talking to like a registered node.
But then, let's say there are easier ways to do this, but then sort of theoretically, it might mean that every dark node needs to also operate an Ethereum node so they can verify the registry. Or, I mean, there's probably way more efficient ways to do it, but
like I said, I'm not 100% sure what part of the system will look like, but that's like one way to do it. And yeah, I think the general idea is there will be like a registry somewhere you can look at and see, know that those nodes are registered nodes.
Okay, yeah. I think then those kinds of attacks don't apply to Ren like the way they apply to Bitcoin and Ethereum, or at least on Bitcoin, because then there everyone can spin up a Bitcoin full node.
Yeah.
Thank you for your time, for your questions, and thank you.
Yes, thank you
so
much for your answers, and Ross.
Yeah, thank you,
I'm
Ross,
very excited
for being here. That was an
into
unexpected deep dive into Frost, which was amazing. So
That's all good.
I'll
I just saw the call pop up and thought I'd drop in.
yeah. So I'll post this on YouTube and let people know if they want to know more about it. They can just listen to this. We don't have to write any docs. No, I'm joking. We still need to write proper docs, but this was awesome. Thank you so much, Rose.
Yes, thank you. Bye.
All good.